All right, friends, here we go. This is question number 2 from the 2014 AB International Exam. A store is having a 12-hour sale. The total number of shoppers who've entered the store T hours after the sale begins is modeled by the function S, where S of t is equal to 0.5 t to the fourth minus 16 t cubed plus 144 t squared for the time interval 0 less than or equal to t less than or equal to 12. At time t equals 0 when the sale begins, there are no shoppers in the store. Now, before we go any further with this problem, I want to make it really clear that S of t, let's go back and read this one more time, it's the total number of shoppers who have entered the store. Total number of shoppers that have entered the store. It's not a rate, it's the total. And I want to be really, really careful about that, and you'll see why in just a bit. Okay, in part A, at what rate are shoppers entering the store 3 hours after the start of the sale? Part A is asking a rate question. S is a total. So what I need in part A is I need to find S prime. Specifically, I need S prime at time t equals 3. So first of all, we're going to find S prime of t, the derivative. And although this is calculator active, let's just go through and find the derivative by hand, and you'll see why in a little bit. 0.5 t to the fourth, bring the 4 down. 4 times 0.5 is 2 t cubed minus 3 times 16, 48t squared, plus 2 times 144 is going to be 288t. S prime of 3 is 2 times 3 cubed minus 48 times 3 squared plus 288 times 3. You'll notice every single one of these is a numerical value, so this is a safe stop. Or you could go through and simplify and say that that's going to be 486. Now, what are the units? S of t is total number of shoppers. We're measuring how this changes over time, which is being measured in hours. And so this is shoppers per hour. In part A, it just says at what rate are shoppers entering the store? And so we're going to give the numerical answer, plus we're going to give the units, and that gets us 1 point. Not too bad. I would expect most students to get this one. Okay, let's go on. Let's look at part B. Part B says, my bad. In part B, find the value of 1/3 the integral from 6 to 9 of S prime of t dt. Then, using correct units, explain the meaning of the answer in the context of this problem. Well, this 1/3 the integral from 6 to 9 of S of t dt, it's this 1/3 and that we're integrating from 6 to 9. That has a total length of 3, specifically 3 hours, and we're multiplying by the 1/3. This is what you would do when you want the average value of a function. And in fact, we just talked about this in question number 1, and I'm surprised that the College Board is asking 2 average value questions, but they are. Oh, wait, I just realized I wrote this down wrong. We want 1/3 the integral from 6 to 9 of S prime of t dt. So what we're looking for, we want the average value. What was S prime? S prime is the rate that shoppers are coming into the store. So this is going to represent the average rate that shoppers enter the store. Now be specific. Give me the time interval from t equals 6 to t equals 9 hours. And you need to give me the units. The units, we look at S prime. If we're finding the average of S prime, the units for S prime are the units for the average, and the units for S prime are shoppers per hour. Great. Now we need to come up with the numerical value, and this is why I wanted to have s prime of t as a function earlier. I'm going to go to my calculator and I'm going to evaluate the integral of 1/3 the integral from 6 to 9 of s prime of t. Well, what was s prime of t? S prime was 2t cubed minus 48t squared plus 288t. Integrate that with respect to t. Let's switch over to the calculator here. And we're going to do 1/3, menu, calculus, numerical integral, from 6 to 9, 2x cubed minus 48x squared plus 288x. Integrate with respect to x, and you're going to get 301.5. So your final answer is 301.5, and we know the meaning is that that's 301.5. That's the average rate that shoppers enter the store from t equals 6 to t equals 9 hours. They awarded 1 point for coming up with the numerical value and 1 point for the explanation, for a grand total of 2 points. Now, you might also be looking at this expression 1/3 the integral from 6 to 9 of s prime of t dt, and you might say, but wait a second, if I'm going to find the integral of a derivative, well then isn't that just the original function? That's true. So you'd have 1/3 s of t evaluated from 6 to 9, which is 1/3 s of 9 minus 1/3 s of 6, or if you saw it, maybe 1/3 s of 9 minus s of 6. Either way, when you plug this into the calculator, you're going to get 301.5. So you could use the derivative of the function and evaluate on the calculator. That's great. Or you could integrate the derivative to get back to the original function, evaluate the function at 9 and 6, subtract, and good news, you get the same answer either way. All right, let's keep going. In part C, now we're going to be given extra information. The rate at which shoppers leave the store, now they're leaving the store, measured in shoppers per hour, is modeled by the function L, defined by L of t is this -80 plus 4400 divided by t squared minus 14t plus 55. Okay, for the time interval 0 less than or equal to t less than or equal to 12. According to the model, how many shoppers are in the store at the end of the sale? Well, let's think about what happens. So number of shoppers in the store at t equals 12, we need to keep in mind a couple of things. If there were people in the store at the very beginning, that's time t equals 0, we need to include that. If you need to go back and read the problem again, feel free. What we were told in the beginning is that there's nobody in the store at the beginning. So that's number of people in the store. I need to add on the number of people who entered the store between t equals 0 and time t equals 12. Now, you've got some options here. If you want to do that as an integral, that's fine, but what you need to integrate is the rate function. That's s prime of t dt. And then from that, you're going to subtract the integral from 0 to 12 of the levers, that's L of t dt. Let me label this. This is in store at t equals 0. This is entered the store from t equals 0 to t equals 12. And this is left the store from t equals 0 to t equals 12. And you can plug all of this into the calculator. You have a function for the derivative, so you can evaluate that. You have another function for the levers, so you can plug that in and evaluate it. And if you do that correctly, you should get 195.701. And they were asked to give the answer to the nearest whole number, so 196 shoppers. That's one way to do that. Another option is we say, okay, well, we still had 0 people in the store at the beginning, but how do I figure out the number of people that entered the store? Well, our initial function s of t told us how many people entered the store. So I'm just going to plug in 12 to that function, and this tells me how many people entered the store in the first 12 hours, minus the integral from 0 to 12 of L of t dt. And if you run through those computations, you're going to come up again with 195.701 or 196 shoppers. A common mistake on this problem was students would integrate s of t, not s prime, and that's where things fall apart. You need to integrate a rate function to get the total. Now, the way they awarded points for this integral from 0 to 12 of L of t dt. They awarded a point for using either s of 12 or the integral from 0 to 12 of s prime of t dt. And then one more point for coming up with the answer, in fact, not there, sorry about that, the 196, because you need that rounded properly, for a grand total of 3 points. Not too bad. One part to go. Let's look at part D. All right, now in part D, using the given models, find the time t at which the number of shoppers in the store is the greatest. Now, greatest, these are always the scary questions for my students. We know that these are always going to be worth a lot of points. Greatest is the same as saying absolute maximum. And we have a process that we're going to run through here. To find the absolute maximum number of shoppers in the store, what we look for first is for the relative maximum. Wherever that happens, that's your candidate. Then we're going to evaluate our endpoints for the interval, which is t equals 0 and t equals 12. And then we're going to state our conclusion. Well, here's the tricky part. The relative maximum is when the number of shoppers in the store, number of shoppers, changes from increasing to decreasing. Well, how do we figure out the number of shoppers in the store? That was by looking at this s of t function minus the integral from 0 to t of, I'll call it L of x dx. This is going to tell us the number of shoppers in the store at any particular time. In order to figure out where this function changes from increasing to decreasing, what I want to do is I want to see where the rate of shoppers in the store changes from positive to negative. Well, to evaluate that rate, I need to take a derivative. So if I take the derivative with respect to t of s of t minus your integral from 0 to t of L of x dx, okay, stay with me on this one. The derivative of s of t is s prime minus the derivative of this integral from 0 to t of L of x dx is just L of t. I need to see where s prime of t minus L prime of t makes a change from positive to negative. Now, this is going to be a little bit tricky. We have a function already for s prime of t. We were given a function for L of t. I need to see where s prime of t minus L of t changes from positive to negative. We're going to need to get to the graphing calculator. So let's do this. And let's see. I'm going to enter a function. And the function is supposed to be s prime. That's my original derivative. 2x cubed minus 48x squared plus 288x. That's s prime minus the new function, which is negative 80 plus 4400 divided by x squared minus 14x plus 55. Take a minute, make sure that you've typed that in correctly. I'm going to double check. 2x cubed minus 48x squared plus 288x minus the other function, negative 80, plus 4400 over x squared minus 14x plus 55. Great. Now let's look at the graph. I know that these functions are only defined on the time interval 0 to 12. So let me make that my x min and my x max. And I don't necessarily like the way this graph looks. It looks like a vertical line. You could, if you want to, you can go and change the window. I haven't worked with this problem. Oh, I didn't mean to do that. I haven't worked with this problem too terribly much. Let's see, I wanted to go from 0 to 12. Let's go up a little bit higher on the y max, maybe to 100. I can see a little bit better what's going on. It looks like the graph is increasing initially. You're positive, and then it comes back down. Well, what am I looking for? My candidate is going to be where the function changes from positive to negative, from being above the x-axis to below the x-axis. So I'm going to go to Menu. I'm going to select Analyze Graph, 0. Go a little bit to the left of the root, a little bit to the right of the root, and according to my calculations, this happens at 5.5451. Now that's your candidate. Now I know from a lot of experience with these problems, we're going to need to do some computations with this. So I'm going to store this value. To do that, you're going to do click, and then you go to var, store var, and then give it a name. I'm just going to call it A. The 5.545 shows up in bold, which means I've stored this correctly. Okay. Let's see where we are now. So what we know is that this expression, s prime of t minus L of t, changes from positive to negative at t equals 5.545, which we're calling A from now on. That's my candidate. What I need to do, though, is I need to go back and I need to evaluate this expression over here at time t equals 5.545, at my endpoint t equals 0, and at my endpoint t equals 12. Now, Mrs. Blakely at East End is a big fan of doing this, and her kids always seem to do so well. So I'm going to do this as well. Here's t, and then here's the expression s of t minus the integral from 0 to t of L of x dx. I need to evaluate this at 0, at 12, and at time A. What we're going to do is we're going to go through and we're going to type all this in on the calculator, and we're going to do it in a really clever way, I hope. So let's see what happens here. Let's go on over to the graph. And okay, here's where I really need to be careful. Let's go back. I've got two different functions here. We've got s of t, and then we've got L of x. I'm going to type in both of these functions into the graphing calculator, and I want to do this really carefully. Okay, we're going to go to Menu. Sorry. We're going to go back to the graph. We're going to do Menu, Actions, Delete All. Yes, I want to delete them all. For my first function, I'm going to type in the 0.5 x to the 4th power minus 16x cubed plus 144x squared. For my second function, that's going to be the L of t expression, the negative 80 plus 4400 divided by x squared minus 14x plus 55. Okay, now let's go back over here. I need to evaluate the number of people in the store at time t equals 0. So I'm going to evaluate the original function at time 0 minus I need to evaluate the numerical integral of the next function from 0 to 0. This is f2 of x integrating with respect to x. Now, you're probably not going to be surprised by the answer. The answer is 0. Well, why 0? This represents the number of people who were in the store at time t equals 0. And you could definitely argue that this set of calculations wasn't necessary. But look what's going to happen now. I need to now evaluate the number of people in the store at time t equals 12. Well, to make life a little bit easier, I'm going to go up, select this, and I'm going to hit enter. This is the copy-paste feature on the calculator. I'm going to evaluate the original function at 12, and I'm going to change my upper limit to 12 and hit enter. And that 195.702, that's the number of people in the store at time t equals 12. We also had that value from before. Finally, I just need to evaluate the number of people at the candidate, which was A. And this is 1,361. 1,361.83. I wish I had more decimal accuracy here showing on my screen, but I know from looking at the College Board scoring rubric it should be 0.832. Check out your values here. Each of these values in the right represents the number of people in the store at this particular time. Where's the absolute maximum? The number of shoppers in the store is greatest at, you could just say t equals a hours, which we know is this 5.545. It's okay to use t equals a as long as you've indicated what a means. Now, what did they do? They awarded 1 point for considering where this expression changes from positive to negative, 1 point for the answer being this 1,361.832, and 1 point for the justification. The justification is sort of all of this put together for a grand total of 3 points. Okay, definitely part D was rough. Part D is the roughest part of this problem. There's a lot going on here. I'd recommend that you come back and look through this one more time. My presentation wasn't as smooth as I wanted it to be. Sorry about that, but it's getting kind of late.